warahmatullahi wabarakatuh. Wait. Okay. So this video I will explain to you maybe some ideas on how to select your point in solving question involving Bernoulli's principle. I believe that some of you might have some difficulties in selecting the points from point 1 to point 2 where we have to solve the question. For example, we want to find what is the velocity and then what is pressure at point 2 or pressure at point 1. So normally question will not give you where the point you should apply Bernoulli's principle. Therefore, it is your job to select your point. Okay. Now, for the first example here, let's say we have a pipe. Okay, we have a pipe. The question. Okay, the flow in a pipe. So this is pipe cross-sectional. If we cut, and we will see that this is the thickness of the wall thickness of your pipe or tubes, and then we have flow of water here. Now in the question give you the cross-sectional area or the diameter here, d1, and then normally the diameter for a pipe is the same throughout. Diameter is the same throughout the pipes. So for the pipe, we have to select the points for section 1. So let's say this is section 1 and this is the section 2. So we have to select the points in the middle of the pipe where we have mean velocity of the pipe. So mean velocity of the flow. So here we have a different flow rate, a different velocity, since we know that because of the no slip condition, each of the fluid layer will flows at different velocity. Therefore, if we want to calculate the velocity or discharge in the pipes, we will have to use average velocity. So Q equal to UA. So here U is average velocity. Or in other words, this is the mean velocity of a pipe, of a flow of fluids. Okay. So we know that the flow of fluid inside the pipes will behave in a parabolic manner. So each of these fluid layer will behave different velocity. Therefore, we take all this velocity and we will get the average velocity. This is the average velocity. And this average velocity is normally at the center of the pipe. Okay, so this is velocity 1, and then we have section 2 also in the middle, and then velocity at point 2. So let's say the question asks us to find or calculate, okay, calculate U2. So how to calculate U2? We have, now this is our objective. When this question asks us about calculating the U2, the most simplest way that we have to calculate U2 is to select the points lah. So for us to calculate U2, we will select U2, this point, as our point number 2. Okay? Or calculate velocity at the section 2. So this is section 2. This is the point number 2. So point number 1 is normally at this cross section lah. Okay. Point number 1 and point number 2. Okay, this is how we select the point. So if in the pipe, okay, point number 1 and point number 2, and the point is in the middle, okay, at the center of the pipe. for both U1 and U2. So after you know and you select the point, then you directly apply the Bernoulli's principle at both points. So the change of energy, so we have to calculate what is the summation or the amount of energy at point 1. So P1 over rho G is pressure energy, plus with U1 square, this is for kinetic energy, and then plus at U1 we have potential energy. This is the summation, the amount of energy at point 1. So we know that in a steady flow or steady state, there is no accumulation. Therefore, the energy balance equation, the conservation of energy, whatever energy here is the same as whatever energy in U1 will at section 1 will goes to section 2. Therefore, in is equal to out. So equal to energy, 2.2, okay, plus U2 square over 2G plus Z2. This is the summations of energy at point 1, and this is summation of energy at point 2. So you must remember it is not necessarily that P1 here is the same as P2 in terms of the value, because it might have changed in pressure energy. So maybe the pressure energy will convert into kinetic energy. And if there is some conversion from pressure energy to kinetic energy or pressure energy to potential energy, and that summation must be the same. That's why this is equal. Okay? So that is how we select the point for velocity in pipe, or selection of point for a Bernoulli's principle in a pipe. So for this question, this is easy. Let's say we have another question where we want to find what is the velocity at the junction. We have one flow rate and then separated into two flow. Okay, this is A, B, and C. Let's say we have QA and then it will separate into B and C. We know that at this point, so QA equal to QB plus QC. The amount of flow rate or discharge at A is equal to discharge at B plus discharge at C. Okay, let's say we want to find what is the velocity at point B. So maybe we have to use continuity equation from here, and then based on the information in the question, we can solve the UB. And if the question asks us about the pressure at B, we cannot use these kinds of equation. No, we cannot use the equation, the same equation as what we use in continuity equation. So in order for you to determine what is the pressure, you have to use Bernoulli's equation. Okay, Bernoulli's equation. So let's say we have to find what is PB. Therefore, our aim is to find what is PB, and we will select PB as our point number 2. So PB at point B would be our number 2. So how can we determine the point number 1? Is it at A or at C? So from this point, you have to see all the information for the point A at area A and area C, or at point A and point C. What kinds of information? So first, you have to check P. So is it given in the question? If it is given, then you select right. Okay, tick right. And then PC. What about PC? Maybe in this point, at this point, there would be no PC, so you have to cancel out. Okay, you X for the PC. And then next, you have to check on UA, velocity. Is there any information on UA? If yes, you tick yes. What about UC? So from continuity equation, we finally can find what is UC. Then you can tick. Because UA and UC can be solved by using UA or UC. If you are using Bernoulli's equation, you can solve this unknown by using a continuity equation. But it is important for you to know that either point 2 or point 1 must have velocity. Let's say you select point UA, A. So UA does not have velocity. But point B, yes, you have velocity. Then you can use continuity equation to remove this unknown. But if both of these point does not have velocity, then you cannot choose. Let's say you have UC and UB. So you select point UC and UB, point C and B. But in C, we do not have velocity. The same as UB, we do not have velocity. Therefore, both of these points cannot be chosen. UB will remain as point 2. Therefore, you have to reselect the point 1, maybe to point A. Okay? So let's say UA here, we goes back to this point. Now this is PA, UA. Now we take a look at Z, ZA. So normally will be given, or normally it is not being given lah. If it is not being given, then you have to cancel out lah. Okay, X for this point, and then ZB. Yes. Okay. Now we take a look at point B. So now I bring this to the point B, UB. So we have to check each of the point, PB, UB, and Z. Sorry, this is not ZB, but ZC. So, and ZB. So let's take a look at this point, okay, UB, at point B. So what about PB? PB is what we are gonna find. So this is remain unknown. What about UB? Maybe UB is been given in the question. Maybe not. If not been given, one of this point or point number 1 must have the values for velocity. Okay. If not, you will make that Bernoulli's equation becomes you make the Bernoulli's equation cannot be solved because it's too much unknown. So this is where we want to find a point where we can minimize the number of unknown. So what about ZB? Normally ZB is been given lah, okay? Because let's say this is a blood vein at horizontal. So every point of this every of this point have the same Z horizontal. So now we already determine PC, UC, ZC, PA, UA, and ZA, and PB, UB, and ZB. Next, we have to choose point number 1. Either we have to choose point number C or point number A. So please choose the point where there is less unknown. Okay. Now PC, we do not have at point C we do not have pressure, so point C cannot be chosen as our point number 1. Therefore, our point is at A because we have PA, UA, and ZA values. So your point to solve what is PB, pressure at B is your Bernoulli's equation must apply at point 1 and point 2. So maybe you might ask me, why do we have to check whether check on P, pressure, velocity, and Z? This is the energy terms in the Bernoulli's equation. If we do not have one of these points, then we cannot solve the Bernoulli's equation. Okay, if we do not have the pressure value in the blood vein, for example, we cannot solve the problem for the PB by using the Bernoulli's equation. If we take a look at velocity, one of the velocity in between these 2 points must contain a values, okay, either UA or UB. If both of these points does not have velocity, then you cannot solve, and that Bernoulli's equation will remain unknown, UA and UB. When you have one point, point A or point B, values of U, velocity, then you can solve that Bernoulli's equation, because we have another equation that can be used, which is continuity equation. Okay, this continuity equation can be used to solve the problems for UA. But you have to remember that the continuity equation is based on this equation. It will not, you cannot say that Q1 is equal to QB. The QA is equal to QB. No, this is wrong. Because from point 1, flows will be divided into 2 sections. Okay, so you have to use this equation in order for you to find what is UA. Okay, so that is for this figure. What if, okay, in the chapter 8, you might see these kinds of figure. Okay, let's say you have pipe, and then you have a faucet here, where the water flows out. So what is the discharge? Calculate the discharge at point at the faucet. So faucet. So what is the discharge? Q at faucet. So what is the discharge? And in the question, we'll be given with the values of diameter here. So the diameter is given, but now we have to find what is the QF. To find QF, discharge at faucet, you have to determine what is U faucet times with the area of faucet. Now area can be solved from diameter. What about UF? So UF can be solved by using Bernoulli's equation. So now we will select this point as our point number 2. Now we have to select point number 1. You can choose at any point in the pipes, or you want to find at the surface of this tank A, for example. You may select your point here, or here, or here, or here, wherever you want to select your point 1. But you must remember, you have to select based on this value: pressure, velocity, and Z. Okay, Z. Normally Z will not have any problems because it will be given in the question. Normally this do not have any problems lah. Now we have to choose, we have to see pressure and velocity at point where you select. Let's say you select here. Okay, you have to check your pressure, you have to check your velocity, and you have to check your Z. Normally you are not being given with the pressure at this point, therefore you cannot select. Because there is unknown here, then you cannot select. this point number 1. What about here? P, U, and Z. Also, normally at this point, pressure will not be given, so you cannot choose this point. The easiest point for you to find, for you to select, is at the surface of this water tank. Okay, tank at the surface, because at this point pressure is P atm, and then we have velocity equal to 0. Why? You need to refer to my previous videos. I've already explained why the velocity at the surface of the tank is equal to 0. And then Z. So Z also can be found throughout this question. So Z is normally from outlet of this faucet up to this water surface. So this is Z. Then choose point number 1 at the water surface of the tank. Then point number 2 is at the faucet. Then apply the Bernoulli's equation, P1 over rho G plus U1 square over 2G plus Z1 equal to P2 over rho G plus U2 square over 2G plus Z2. Okay, so you may cancel out whichever values that is 0. Okay, whatever value can be zeroing. So here we know that U1 can be 0, P1 also 0, because P atm. Your Bernoulli's equation is gauge pressure, so we can exclude the P atmospheric in your calculation. So we have this equation. So rearrange to find what is the pressure, what is the velocity at point 2. So what about P2? P2 is go to atmospheric pressure. So P2 is P atm. So you can cancel out this 0. So you have Z1 equal to U2 square over 2G plus Z2. Rearrange the equation to find what is velocity. Okay. So that is a few example where how to find your point to solve Bernoulli's equation, or to apply Bernoulli's equation. You must remember that the points you select must be in one streamline. So if you have another streamline here, we have tank and then we have orifice. This equation, we have tank A and tank B. So the velocity at here is, maybe the velocity is given here, pressure also been given, and then Z can be found, but you cannot select point 1 here, point 2 here, because it's not in a single streamline. To apply Bernoulli's equation, it must be in a single streamline. So 1 to 2 here is in one single streamline. So you cannot choose another streamline and to apply the Bernoulli's equation. So the energy at this tank is totally different with the amount of energy in this tank. Therefore, you cannot choose another streamline to compare with point number 2. Okay? That's all. Thank you.